Hi, everybody. Before I formally start, I have a survey that I have a tradition of doing at Django events. How many of you started using Python because of Django? Maybe a third. And how many of you got hip to Django Reinhardt, the musician, because of Django? The more important question. Okay, more of you need to listen to Django Reinhardt. Okay. I'm going to share with you something that I'm very excited about. I haven't been excited about a web technology like this for many, many years. It's called Service Workers. And let's just dive right in with a demo. I run a site/company called SoundSlice that does interactive music lessons. The idea is that you learn music best if you can see a video, you can hear what it's supposed to sound like, and then it's all synced with music notation. So let me do a little demo here. Make the video a little bit bigger, and the premise is you can hit play and hear what it sounds like, see what the guy's doing, and then you can see the notes light up. And if there's a bit you want to work on, you can just highlight it, it'll loop it, you can slow it down without changing pitch, blah, 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 a bunch of other stuff. But the main thing I want to call your attention to is this Save Offline button at the bottom. What does that do? Let's open up Chrome DevTools and go to the Network tab. And I don't know if you know this, but you can actually fake offline mode if you hit offline there. So let's go offline, and what normally happens if you view a web page when you're offline, you get the browser's default offline message, which of course differs based on the browser. It's ugly. In some cases, it's a game. Did you know that in Chrome, the offline thing with the little dinosaur is a game? Do you really want your users to play games if they can't access your site? No, you want to do something cool if your users access your site while they're offline. So let's try, now that we've disabled the internet and faked offline mode with our Chrome DevTools, let's refresh the page and see what happens on SoundSlice. If we refresh the page, you actually see a nice message. It says, you're offline. You haven't saved anything for offline study, but you can do that if you want to. And as I click through the site, no matter what page of the site I'm on, that's the actual URL. It shows me that nice offline message instead of the ugly thing that you can't control that the browser gives you. What on earth is happening there? Let's back up a little bit. First, let's put our Wi-Fi back on and go back to that site, the original lesson that I originally showed you. And now go to the bottom and look at that Save Offline button. If I click that, it'll download a bunch of stuff, and eventually it'll say Offline Mode Enabled. Ooh. Now let's turn our Wi-Fi off again, pretend we're offline, and refresh the page, and everything is still working. I can press play, videos can still seek, I can still slow it down. Everything is still exactly the same as it was when I had an internet connection. When I first experienced this, I had one of those very rare professional moments where I said, oh my God, this is big. Are any of you old enough to remember when Google Maps first came out? Yeah, or when Gmail came out. And you were like, whoa, this is possible? For some reason, the last maybe decade or so hasn't had that many advances in just core web technology. There have been a lot of advances regarding the tooling, but just fundamental web experience technology hasn't had that many advances. And this, I think, is one that I'm super, super excited about. So how does this work? The rest of my talk is going to go into the details. By the way, if you're offline and you click through the rest of the site now that I've saved something offline, it says, looks like you're offline, but here are the pages that you've saved for offline usage. So the user experience, the intended usage is you go to SoundSlice, you're learning your bunch of licks or tunes, you click Save Offline for the ones you're learning, and then later, when you're offline, all you need to remember is just go to soundslice.com and it'll show you them. You don't have to bookmark the individual pages, for instance, which would be kind of a bad experience. So let's talk about how this works. A clue is here in the DevTools. Let's make it a little bit bigger. You know, for every, here we see all the assets and all the files that are being accessed by this page. And a hint is that a lot of them say, from service worker. What on earth is that? Well, it's something very, very beautiful, which I love. So this is a little homage to the channels talk by Andrew yesterday. This is how we're accustomed to websites working. You've got a request, and you send it to the internet, to Django, and it returns a response. With a service worker, it works a little bit differently. Your browser makes a request, but it gets intercepted by this thing called a service worker first. And the service worker can choose to forward that request to the internet. It can massage the request. It can get the response back and massage that, or not. Or it can just create a response dynamically and then send it back to the browser. I'll explain what that actually is. Just at this point, it's this nebulous concept of a service worker. So without the service worker, or if you have a service worker that is a no-op, it's just the simplest possible service worker, it doesn't do anything. It just forwards all requests to the internet and brings back the responses and brings them to your browser. But where it gets really interesting is when your service worker intercepts requests such that they're not even passed to the internet. And you have two huge advantages for that. Number one is performance, because if you don't hit the internet, you can basically do things instantly, and it is eye-poppingly fast to see some of this stuff work. The other advantage is things work offline. So let's talk about what you can actually do. A service worker has basically three bits of functionality that it has some more, but the three core ones are an ability to make requests to the web. That's called the Fetch API, which is JavaScript API. It's actually available in just vanilla JavaScript in your web pages if your browser is new enough, but fortunately, all browsers that are new enough to support Service Worker support Fetch. So you can use it safely within a service worker. You can also cache. So just as in the Django cache API, you can set things, you can get things, you can clear them. It actually has its own cache. It's separate than your browser's cache. It's the service worker cache. And then you can run arbitrary JavaScript, which is how you glue all this stuff together. So the way that this works in practice is somebody visits soundslice.com, which, for example, there's the initial request and the initial response. Nothing there is different than what we've been doing for 10 years or more. But in that initial response, within the HTML markup is a little bit of code that says, register a service worker for this domain, soundslice.com. And so it says, okay, here's the URL of the service worker, which is just a JavaScript file. It's going to do the request and get that service worker, which may or may not be before the rest of your page loads. So there's this weird asynchronous feel to this. But once your browser has the service worker, it treats any request that your browser makes to your domain as going through the service worker. So any subsequent request will go through the service worker. That is everything. That's not only pages that you navigate to, but any assets that those pages might be requesting, JavaScript, CSS, images, any kind of media files. So that's the basic concept. In your markup, you say, I have a service worker, and then your browser sort of does the rest. Somewhere in your HTML, you put, if my browser supports service worker, register it, and you pass it the URL to the service worker, which is just a JavaScript file somewhere on your domain. And in that file, serviceworker.js, I know this is JavaScript, but we'll get to some Python later. In that file, the most important bit is a fetch handler. And what this means is it's a way of reacting to any fetch that your browser does. So for things on your domain. So for the sound slice service worker, this thing acts for any assets that my browser ever requests to soundslice.com/whatever. And you get past event, and you can access event.request, which is basically very similar to the Django request object. It has things like the URL that's being requested, the method, and so forth. And you can then poke at that and do things based on it. Event respond with is the formal API. You're going to respond with such and such response. Something is not valid code. So the simplest thing you can do, and the way you can emulate your built-in browser behavior, is just respond with and then fetch the request. So if you just have that, it would be the same as not having a service worker installed at all. Or in fact, if your fetch method doesn't do anything, then your browser will fall back to its default behavior. But of course, that's boring. Let's actually do something interesting. In this example, I'm checking the method. If it's a GET request, then check the cache, and then have a promise, and then do an AJAX request, and then a fetch, and then do this thing, and then make sure you have this URL and irregular expressions, and it's just, let's not deal with the JavaScript at this point. I'm intentionally not going into the code and the APIs and the syntax. I just want to give you the concepts. So there's a lot of JavaScript that you have to deal with. But let me give you some possibilities on what you can do. Number one, as I've mentioned, is you can cache things. So for instance, you can say, oh, it looks like my page is requesting my main.css. I can check the cache for that, the service worker cache, and if it's in there, just return that, so we don't have to hit the network at all, whatsoever. Or you can add to the cache. Oh, I checked the cache, it wasn't in there, let me hit the network, and when I get the thing back, I'll stick it in the cache so that next time the user visits it, it won't have to hit the network. You can also preload assets. There's a little hook in your service worker to run a bunch of code when the service worker is activated on the user's machine. And one very common thing to do there is to just preload a bunch of stuff that will be probably used on every page, such as your core CSS, maybe some JavaScript. You can alter data depending on who your user, maybe your user's capabilities. So you can get kind of crafty. And most interestingly, you can enable offline usage, which I demonstrated. And then the coolest thing of all, I really have to hand it to this guy, Dr. Gleb Bamutov. He put an entire JavaScript web framework in a service worker. And if you think about that, what that means is you have the initial download of the service worker, and then any navigation to any URL on the site will be handled by the service worker, and no network activity happens whatsoever. So all the URL parsing, routing, templating, the view and controller logic is all in the service worker. This is one of the more amazing hacks I've ever seen. I hope that some of you are inspired and port Django to this, possibly using some of Russell's tools, Batavia, so that you can put Django in JavaScript form in a service worker. It would be amazing. Please do that and talk about it at DjangoCon next time. There's a big caveat to this, which is it only works in these 3 browsers. Chrome has supported it for a while. Firefox just added formal support in a real release about a month ago. It's super bleeding edge. And Opera also supports it. As for the others, Internet Explorer is, of course, dead, so it doesn't support it and never will. But the new Microsoft browser, Edge, will support it eventually. They're working on it. And of course, the elephant in the room, Safari, Apple has said it's in their 5-year plan. The conspiracy theory, of course, is that this leads to web applications that compete with native apps because they're offline enabled and with some other functionality that I haven't gone into. So Apple doesn't really have an incentive to do this, but one of my goals, not only in giving this talk, but in promoting this in the community, is to get more and more people using service workers so that more pressure gets put on Apple to actually implement it. So right now on iOS, none of this will work. But this is DjangoCon, so let's talk about how to do this with Django. I'll give you a couple of things that you can do to your sites today. So for those 3 browsers, Chrome, Firefox, Opera, and soon Edge, you can have some cool stuff. Number 1 is, as I mentioned, replace this horrible default browser offline page. And there's that dinosaur, which is the game in Chrome. But don't do it now. It's not that fun of a game. What you can do is, of course, replace that with a very nice branded, hey, you're offline right now page. Why would you want to do this? I can think of at least 2 reasons. It's better branding, it feels happier, it's just a nicer experience. And number 2, depending on the nature of your site or application, there may be some crucial information that you can put in there. Say you run a restaurant website, you can just stick the hours and the address and the phone number right in there, so they don't have to be online to access it. Of course, the caveat is they have to have accessed it at some point in the past for the service worker to exist. That's one thing always to keep in mind with these things, because your browser didn't know that you wanted to visit that page. So how would we actually do this? This is the most basic implementation of service workers. In your JavaScript service worker code, there's a registration bit, and you just download your offline page. You make a nice offline page. Maybe you embed some inline CSS in there. You can actually just hard code the markup directly in your service worker JavaScript. It doesn't have to be a separate file. But anyway, you create that so that when your user initially downloads the service worker, they're getting that offline page as well. And then in your fetch handler, you basically do, this is pseudocode, but you do a try except. You try to download a page, and if there's a network error, fall back to the offline page. Makes sense, right? Okay. The second, more advanced way of using this is maybe what I might call cumulative caching. And that means as the user visits pages of your site, you'll just cache them as soon as they're visited, so that the next time they visit them, they'll be cached, and they won't need to hit the network. And that's relatively straightforward code. You always, in your service worker, check, is the page in the cache? If so, use it. If not, download the page and save it in the cache. This is similar to what many of us do in our Django views with caching at the Django level, but of course this is at the level of your users' browsers, so you avoid the network completely. And then you can also take an approach where you make your users actively request something for offline usage, which I again demonstrated earlier. So there's this, on SoundSlice, the Save Offline button. The way that works is, in the service worker, you always check the cache. If so, you pop it in there. If not, you download it from the network, but you don't cache it, because we only want it to be in the cache if the user explicitly requests it. And then in the site UI, you add a handler for that click on the Save Offline, and that's when you save it into the service worker cache. So, relatively straightforward. There's a couple of problems, though, with what we've been talking about here. Number one is that we're caching a lot of stuff. Granted, we don't really have to worry about it because it's on our users' machines, but there is a limit on the number of the amount of data that can be stored in a service worker on a user's machine. I actually don't think it's specified. It varies by the browser. But if you look at these two SoundSlice pages, you realize that although the content area is different, the wrapper of the page is the same. So the stuff in the ugly yellow is different, but the navigation and the player and all that stuff is the same. So really, should we be caching that with every single request? And the answer, of course, is no. What we want to cache is, we want to just download this thing once, basically the shell of your application, the navigation, and then just deal with the stuff that goes inside of it as the user navigates from page to page. And if you are familiar with Django, you may look at that and say, what is that? Well, it's probably my base template. And if you're using Django's template inheritance in a reasonable way, chances are you can just sort of use your base template and just not fill it with anything and get something approximating that page, the shell of the page. And this leads us to an approach of building modern web applications called the app shell infrastructure or architecture. This was devised by some developers at Google. And the idea is you give your users the app shell at the time that the service worker is instantiated. And as they browse through your site, they don't have to download the shell again. They just get the stuff that's different for every page. So there's these same two huge advantages as before. One is it's super fast, and two is you can possibly work offline if you develop it the right way. The way this generally works, the way it works for SoundSlice, is in your registration of the service worker, you download this app shell, which is just that markup with nothing in the middle. And then on every fetch, you just immediately return the app shell. Of course, if you did that, you'd have some problems. By the way, this is what that looks like. You just never hit the network. If you did that, you would have some problems. Every page on your site would look like this, because the service worker is just saying, oh, it's a URL. I'll give the app shell. There's the last bit of it that is actually pretty clever that they came up with, a very nice approach to handling this. So a service worker instantly gives you this, which results in a page load time of 0.001 seconds. Just instant, feels really cool. And then in that app shell, you put a little bit of JavaScript that makes an AJAX request at the time of page load, so on DOM ready, that says, retrieve the current URL and stick a little extra thing on the URL from app shell equals 1, a little flag that tells Django that, oh, it's the app shell requesting it. That way, Django knows that it can put just the content, not the entire thing. And Django sees that and does something different, possibly rendering it with a different template, possibly doing whatever you need to do. And the app shell page then gets that response and just sets the inner HTML of the content to that. And you're done. On the Django side, I'll show you a little trick. I don't know if how many of you know this, but you can actually make your parent template in the template language dynamic. It can be a variable. So in my fake view here, I check request.get for this magic from app shell. And if that was given, I set the template name to, what did I use? Empty.html. Otherwise, use base. And then render the template with that variable parent template name. And then in the template, notice there are no quotes around base template. That is a variable. So that's how I would implement this for the Django bit of it. Does that make sense? Straightforward? Okay. So as a result, here's what it sort of feels like as the user clicks through the page. I'm going to click, and notice that with every page view, it's basically instant. The navigation doesn't even like twitch. It's just there. It's amazing. Just ever since I implemented this on the site, it's like, I just want to use this more. and it's so fast, it's so just fluid. So it's, you know, there's the difference between, or there's a distinction between performance and perceived performance. And this is definitely a hack of the perceived performance, because you're giving your user something immediately, even though it might not be what they really want. Who wants to see the navigation again and again? But it makes them feel that the site is very fast. And there's another big problem, which is one of the only two problems in computer science: cache invalidation. The problem is, if you're storing all of that in your service worker cache, when do you update it? Especially if you're favoring or prioritizing your service worker stuff and using the network as a fallback, how do you know that the service worker's cache needs to be updated? I have a couple of different approaches, and I actually use all of these in my own service worker because different things require different approaches. The first one is, for any static assets, make sure that the file name includes a hash of the file's contents. So anytime you update your CSS, the file name will actually change, and of course there are many asset managing packages for Django that will do that for you. I just have my own thing. It's just a dumb little MD5 of the media. So with this, you get cache busting for free, because as soon as the media changes, the service worker will say, oh, that's a new file, it's not in the cache yet. So if you're already hashing your media files, for instance, for doing far future expires headers with traditional HTTP cache, you're in great shape. Number two, for the app shell, how do you know when that's updated, given that the service worker is instantly responding with it on every single page view? One approach, which I do for one of my 2 app shells on SoundSlice, is I just remember the date and time it was updated, and on every fetch, I just, as an aside, check that, see how long it's been since I last updated the app shell, and if it's been more than however many days or hours, grab a new one in the background, so on the subsequent response, the new app shell will be used. Another approach is that you can just always refresh the app shell in the background on every fetch request. Of course, again, it's important to keep in mind the app shell won't actually take effect until the next page view, which leads to a problem which I'll talk about in a minute. And then, of course, you can give your users a way of clearing the cache, as I explained previously. Now, if you're dealing with the app shell that has navigation, it may have stale data in it, and this is a big problem that I ran into. For instance, on SoundSlice, the navigation has the current user username and avatar. And I could solve this by inserting that with JavaScript, but I choose not to because that just adds complexity to the system, and I prefer to have all the templates in one place. So that, with that, the requirement is that my app shell include the user's avatar and username. So what happens when you log out? Well, the app shell still shows you being logged in. Here's a hack that I came up with that is the best thing I could think of. Maybe some of you have better ideas to solve this. One is, on every page view, you load a new app shell in the background. And in the content response that gives you the content of the page, you also include the user's ID, or some information about the user. And in the service worker, or in the app shell, you check that user ID versus you compare it to your app shell's ID, and if they differ, just refresh the page. So it's a little bit ugly, but it solves that problem of things being out of sync. So let's recap. Service worker is this thing that sits between you and the site you're looking at. It lives in your browser, and the site installs it in your browser, and it lives forever and affects any requests made to that domain or from pages on that domain. You can use this app shell architecture to give your users near instant performance and also enable offline usage. And you can do this little Django hack to change the contents of the request based on whether it's coming from the app shell or not. And that's basically it. So I challenge you, given that DjangoCon's site is open source, it's on GitHub, I thought it would be a nice challenge to say, why don't you try adding a service worker to the DjangoCon Europe website? I think it could be a nice exercise. Maybe you can collaborate with people at the sprints if you're sticking around, or just do it on your own time. I haven't told them that I'm encouraging people to do this, so be nice. Good thing is, if you get it working, you can contribute it back and improve our community. If you can't get it working, this is the last talk anyway, so it's not like it's really going to affect anything. But what I would suggest putting in there is the schedule, the location, all the stuff that if you're on the lousy conference Wi-Fi, you can't maybe sometimes access it, but because you had accessed the site before, it was in your browser service worker. All right, and I wanted to leave time for questions. Thanks for your attention. Do we have time?
We've got time for questions, but more or less 2 or 3, not 6. So I'll start with Marcus here.
Thanks, Adrian. Can you explore the differences between the caching in the service workers as opposed to the caching or long-time caching with extended header cache time or cache validation times?
Good question. There probably, in practice, is no performance difference. Where this really comes in handy is when you're doing something dynamic with it. So if you're doing far future caching for your static files, I don't know if this will, on its own, get you much. It's a good question.
Hello. Have you had any experience with, or do you have any suggestions for using service workers in an offline mode to kind of like capture the user submitting data and then trying to replay that later so that like, yes, if I'm using it on, you get what I'm trying to ask.
Yeah, that's an amazing idea. I personally have not done that, but I am looking forward to doing it someday, and that's completely possible. You just intercept those requests and save them in a cache. You can also access the, what is called IndexedDB, the JavaScript database thing, and stick stuff in there. So yeah, totally possible and awesome.
Can service workers intercept WebSocket requests and WebSocket connection requests, and do you pretend to be a WebSocket as well as pretending to be the rest of your server?
I do not know. I had a feeling someone would ask that, and I made a note to check, and I didn't. Sorry.
All right, one more.
My question is related a little bit to Mark's one. Have you considered sending an event through a channel when someone logs out, so to invalidate the cache of the app shell?
How would... Oh, you mean using
like
the
if
channels?
Like someone logs out, you push a notification to through a channel to the browser to invalidate the cache, and then on the next request.
Sure, that's a nice solution to it, and my problem is I'm not using channels yet. I'm not cool. I will do that.
Thank you very much, Adrian. Amazing talk.